Okay guys, this is Worm from Worm's Maths Academy, just running through Specialist Academy Specialist Maths Exam 1 2017. A few people have asked for it and I didn't realize I hadn't done it. So, okay, find the equation of the tangent to the curve at the point 1, 1. So we obviously need to find the derivative, which is implicit differentiation. So the first one's going to be a product rule. So let's diff this with respect to x. 3, leave that alone, y squared, plus, if we derive y squared with respect to x, we get 2y dy dx, of course multiplied by 3x, plus, if we derive this with respect to x, we're going to get 2y, when I derive y, I just get 1, so I get 2 dy dx. That equals, when I derive this with respect to x, I get 1. So from here, we want to bring our y squared to the other side and group together our like terms. So we get dy dx, and then I've got 6xy plus 2 equals 1 minus 3y squared. So we get dy dx is equal to 1 minus 3y squared on 6xy plus 2. And I forgot the y. 6xy plus 2. Therefore, dy dx, given x equals 1, y equals negative 1. If I put y equals negative 1 in, I get 1 minus 3, which is negative 2. If I put xy in, I'm going to get negative 6 plus 2, which is negative 4. So my gradient is a half. So I've got m is a half, x is 1, and y is negative 1. So y plus 1 equals a half, x minus 1. Therefore, y is equal to a half x minus a half minus 1 minus 3 on 2. So that's our equation of the tangent. Okay. Whew, this one doesn't look very nice, does it? Sort of looks like a 10, but it's not. Okay, I think it looks like an irreducible partial fraction. So x, 1 plus x squared, is equal to a on x plus bx plus c on 1 plus x squared. Okay, so we're going to get 1 is equal to a, 1 plus x squared, plus x times bx plus c. Okay, if you let x equal 0, we're going to get a is equal to 1, because this whole thing is going to equal 0. If we let x equal 1, we're going to get 1 plus 1 is 2, so we're going to get 1 is equal to, a is 1, so, and then that's going to be 2. We let x equal 1, so we'll get plus b plus c. So therefore we get b plus c is equal to negative 1. Let x equal negative 1. So you can see what happens there. I'm going to end up with this pretty much the same thing. 1 equals, if I put negative 1 into that, I'm going to get 2 still. If I put negative 1 into this, I'm going to get plus b minus c, which ends up being quite nice. B minus c is equal to negative 1. Equation 1 equation 2. Okay, if we add them together, 2b is equal to negative 2, so b is equal to negative 1, and if b equals negative 1, c will equal 0. So we know the integral from 1 to 3 of 1 on x, 1 plus x squared, we know that a is 1, and then we know that b is negative x, so we can just say negative x on 1 plus x squared dx. Now, we know if we integrate that, we get log e mod x. We know if we integrate this, we need to put a 2 on top, which means we've got to put a half out the front. So, negative a half log e 1 plus x squared between 1 and root 3. Okay, so log of root 3 minus, if I put root 3 into this, we're going to get 1 plus 3, which is 4, and then the square root of it, so log e2. And then minus, log e of 1 is 0. Log e of 2, I'm going to get minus log e of root 2, because I've got that half out the front. So we have log e of root 3 minus log e of 2 plus log e of root 3. Have I buggered anything up here? It's got to all be under the square root, so we can make that root 4. Okay, plus, somehow I ended up with a 3 there. Let's fix this up. Okay, so here we get root 4, and here we've got root 2. So our answer is going to be log e square root, 3 times 2 is 6 on 4, which is log e root 3 on 2. And that's in that form. A and b are positive integers. Okay. Here we've got the conjugate root theorem. Because if we know 1 minus I is a solution, then 1 plus I will also be a solution. So we can say z minus 1 plus I, z minus 1 minus I. When we expand that, that's z minus 1 squared minus I squared, which is plus 1. Which is z squared minus 2z plus 2. Find all other solutions. Okay, so we know that if we had some value, z minus b, if that was my other solution, times z squared minus 2z plus 2, that would have to equal z cubed plus az squared plus 6z plus a. So we know negative 2b has to equal a. What else do we know? We know, so that's just from doing those two together. Actually, let's do it in purple or something. So those two together have to equal that. We've got az squared. So what are the things that give us z squared? Negative bz squared. And then I have got negative 2z squared. So negative b, negative 2 is equal to a, that coefficient. Okay, so from here, we can let these two things be equal. So negative 2b is equal to negative b minus 2. So negative b is equal to minus 2, so b is equal to 2. So therefore, if b is equal to 2, then what will a have to equal? It doesn't actually tell us to find a. It just says to find other solutions. So therefore, our other solutions are 1 plus I and b equals 2. So there are other solutions. Other solutions. Okay, the volume of drink dispensed into milk bottles varies normally with a mean of 298 and a standard deviation of 3. The soft drink is sold in packs of 4 bottles. Find the approximate probability of the mean volume of the soft drink per bottle in a randomly selected 4-bottle pack is less than 295 mils. So we know mu is 298, sigma is 3, n is 4. E of x bar is 298. Sigma of x bar is 3 on root 4, which is 3 on 2. We want the probability that z is less than 295. Well, x is less than 295, but we're going to say 295 minus 298 on 3 on 2 to get a z value. So I've got negative 3 on 3 on 2, so that's the probability that z is less than negative 2, which we know is approximately 0.025, because if you draw a curve, 0, 1, 2, that's about 95%. So in here's got to be 2.5%. I think the exact value is 0.023, but I think either would be fine as an answer. Okay, relative to a fixed origin, the points B, C, and D are defined respectively by position vectors. Those. Given the magnitude of BCD is pi on 3, find A. So I've got to find CB first, which of course is negative 2, 1, negative 1, plus 1, negative 1, 2, which is negative 1, 0, 1. CD is equal to negative 2, 1, negative 1, plus A, negative 2, 0, which is A minus 2, minus 1, and minus 1. Okay, the length of CB is going to be 1 squared, 1 squared, it's going to be root 2. The length of CD is going to be the square root of A minus 2 squared. And then plus 1 plus 1, so plus 2. Now we know cos of pi on 3 is equal to CB dot CD on mod CB CD. Cos of pi on 3, 1, 2, root 3, that's a half. So we get a half is equal to CB dot CD. That's going to give us 2 minus A, because when I times that by negative 1, 0, and then minus 1, on the square root of a minus 2 squared plus 2. Now let's cross multiply these. So a minus 2 squared plus 2 is equal to 2 minus 1, of course, is just 1. When we multiply that across, we're going to get 2 minus 2a. Now remember, this isn't complex, and I've got a square root. So if I've got a square root, this side must be greater than or equal to 0. So 2 minus 2a has to be greater than or equal to 0. Therefore, minus 2a has to be greater than or equal to minus 2, and a has to be less than or equal to 1. So when we go to solve this, we get a squared minus 4a plus 4 plus 2 is equal to, we've got to square the other side, which is 4 minus 8a, and then plus 4. From here, bring it all to one side. A squared plus 4a, that's not an a. A squared plus 4a, 8 minus 2. What have I done? Oh, I know. I forgot to multiply that by this. So root 2, which means it's going to change all of that on the bottom. So we would get just a 2 inside. So we'd get 2a minus 2 squared plus 4 when I multiply that root 2 in. That's equal to 2 minus 2a. So here we get 2a squared minus 4a plus 4 plus 4, and that equals, when we square this, 4 minus 8a plus 4a squared. Okay, so I got 2a squared, 4a squared, and let's just clean this up. 2a squared minus 8a plus 8 plus 12 equals 4 minus 8a plus 4a squared. Okay, let's bring all of this to the other side. So we get 2a squared. I've got minus 8a plus 8a, they cancel each other out. And then, if I bring that to the other side, I get minus 8 equals 0. 2a squared equals 8. A squared is equal to 4. A is equal to plus or minus 2. However, a is less than or equal to 1. So therefore, a equals negative 2. Okay, find f dash of x and state the largest values for which f dash of x is defined. Okay, so let's just write f of x is sine inverse of x to the negative 1. So f dash of x is negative 1, and we're going to have sine inverse of x to the negative 2. When we derive sine inverse, we get 1 on square root 1 minus x squared. Okay, so we would get negative 1 on root 1 minus x squared, arc sine, we'll say, arc sine of x squared. Okay, sine inverse can only be between negative 1 and 1. This thing here, because it's on the bottom, 1 minus x squared has to be greater than 0. So 1 plus x, 1 minus x has to be greater than 0. So that's going to be between x as an element of x is an element of -1 to 1. However, what about if it's 0? On the bottom, what's inverse sine of 0? It's 0, so it also can't equal 0. Because if x was 0, sine inverse of 0 is 0, so I'd be dividing by 0, so it can't be possible. So that's f dash of x. And then that's our domain. -1 to 1. It can't be -1 to 1 because that will equal 0. And it can't be 0 because then arc sine would equal 0. Okay, the position vector of a particle moving along a curve is given by that function. Find the length of the path that the thing travels. Okay, so x of t is cos cubed t. Y of t is sine cubed of t. So dx dt is -3 sine t. So -3 down to the front. When I derive cos, I get sine, and then cos squared t. dy dt. It's not a t, that's an x. Dy dt. When I derive that, I'm going to get 3 cos t sine squared t. Now we know we're going to have to square them and add them together. Let's add them together. So let's say dx dt squared plus dy dt squared is equal to 9 sine squared t cos to the 4 t plus 9 cos squared t sine to the 4 t, which of course we can take out a 9, sorry. So that's equal to 9, and we've got sine squared t cos squared t, and what's left over? Cos squared t plus sine squared t. And what do we know that equals? We know that that equals 1. So then this is the integral of from 0 to pi on 4, the square root of 9 sine squared t cos squared t dt, which we also know is 3 times the integral from 0 to pi on 4 of sine t cos t dt, which we know is 3 on 2, 0 to pi on 2 of sine 2t dt, because we know 2 sine t cos of t is equal to sine of 2t. So then if we want sine t cos t, it's going to be half of that, which is why I divided it by 2. Somehow I did this magical thing where I put a 4 up here. So let's change it back. Okay, so we get 3 on 2. When I integrate sine of 2t, I'm going to get negative a half cos 2t, 0 and pi on 4. Okay, so we get 3 on 2. Cos of pi on 2 is 0, so negative a half times 0, minus cos of 0 is 1, So negative a half. That's 0. So we end up with 3 on 4 units. So that's our length of the particle moving along the curve. How many questions has this got? Okay. A slate field representing that differential equation is shown below. Sketch a solution of the differential equation for y of 1, negative 1 equals 1. So, oops, y of negative 1 is equal to 1. So I'm saying it's about there. So I think it goes across. I think it looks something like that, but we can't be 100% sure. Done like that. Maybe over here. I hate trying to sketch these things. I reckon as long as it's pretty good, they're not going to. Okay. So sketch a solution curve of the differential equation corresponding to the condition that, and hence estimate the positive value of x when y equals 0. So when y equals 0, when y equals 0, wow. I would say like 1.8. So when y equals 0, x equals 1.8 approximately. Yeah, I don't really think there's a hell of a lot of difference. It's going to be between 1.8 and 2, I reckon. And it says the positive value of x, so we're not looking at this one, we're looking at the other one. I don't really like that question. Okay, solve the differential equation. dy dx equals negative x on 1 plus y squared with the condition that express your answer in the form that. Okay, so 1 plus y squared dy is equal to negative x dx. Yep, didn't see that. Okay, it's not too bad. Y plus y cubed on 3, I'll say equal to negative x squared on 2 plus c. They've all got to be integers. Okay, we know y of negative 1 equals 1. Therefore, negative 1 plus minus, no, y is 1. So it's going to be y is 1. So 1 plus 1/3 is equal to negative 1 squared is 1, but I'm going to get negative 1/2 plus c. So c equals 4/3 plus 1/2, which is 1/6. That's going to be 8/6 plus, put it on 6, 3, 11 on 6. Okay, so c is 11 on 6, and we have got y plus y cubed on 3 plus x squared on 2, and then if we put that c across the other side, negative 11 on 6 is equal to 0. Okay, so we've got to times it through by 6. So 6y plus 2y cubed plus 3x squared minus 11 equals 0. 2y cubed plus 6y plus 3x squared minus 11. I normally worry. Stupid thing wasn't me. It's ay cubed plus by. So let's say 2y cubed plus 6y. That looks pretty good to me. It's in that form. You have to be getting pretty close. A particle of mass 2 kilos with an initial velocity of 3I plus 2j experiences a constant force for 10 seconds. The particle's velocity at the end of the 10-second period is that. Find the magnitude of the constant force. So our acceleration is our change in velocity over change in time. Our change in velocity is 43 minus 3, which is 40. I. 18 minus 18 minus 2 is minus 20. J on 10 seconds. So it is 4I minus 2j. Our force is equal to our mass times acceleration. Acceleration is that, and our mass is 2. So therefore our force is equal to 2 times 4I minus 2j, which is 8I minus 4j. So that's our force, but it says find the magnitude of the force. So magnitude of the force, square root of 64 plus 16, which is 80, which is 16 times 5, so 4 root 5 newtons. Okay, find the displacement. I'm starting to get a sore neck. Find the displacement of the particle from its initial position after 10 seconds. So we know A of t was 4I minus 2j. So V of t is 4ti minus 2tj plus some constant. We know its initial velocity is 3I, so V of 0 is equal to 3I plus 2j. So 3I plus 2j is equal to c, because they're both going to be 0. So we end up with V of t is 4t minus 3 plus 3. I, don't forget to put a bracket around it. And then I've got 2 doesn't want to work. So 2, that's at 2 minus 2t j. Now we need to find x of t. So x of t is 2t squared plus 3t I plus 2t minus t squared j plus d. Initial velocity So if we let the initial displacement be 0, when t equals 0, x equals 0, then d will equal 0. So from there, because we want to work out the displacement after 10 seconds, if it was 0 there, when t equals 10, x of 10 is equal to 2 times 100 plus 30, so 230i minus 2 times 10 is 20 minus 100, 80j. Find the displacement. So that's our displacement from the initial position after 10 seconds. Got to be close to the end because I feel like this is taking a while. Okay. d dx of arc cos x is equal to that. Okay. So d dx of x times arc cos, or arcos, it's the same thing, acos, arc cos x on a. So if we derive that and leave that alone, we get arc cos of x on a. If we derive that and leave that alone, we're going to get minus x times, or plus minus x times minus 1 on square root a squared minus x squared, which is, of course, arc cos x on a minus x on, I don't know how they show that's just stupid because like you pretty much just go straight to the answer. A squared minus x squared, and there's only 2 lines. State the maximal domain and range of this thing. So our cos inverse is between -1 and +1 because it's been dilated factor 2 from the y-axis. Our domain is going to be x as an element of -2 to 2, and our range is usually, for arc cos, it's 0 to pi, but because it's square rooted, our range is going to be from 0 to root pi. Find the solid volume of revolution. Okay, when the region bounded by the graph y equals f of x and the lines x equals -2 and y equals 0 is rotated about the y-axis. So when y equals 0, if we let y equal 0, the graph of f of x, oh, we just worked that out. It's going to go to 2. X equals 2. So our volume is going to be pi from -2 to 2 of arc cos x on 2 square rooted and squared dx, which is pi -2 to 2 arc cos x on 2 dx. Didn't we just work something out up there? Okay, so if that was y, arc cos this, when I bring that to the other side, oh, this is ugly. Okay, so when we integrate this, arc cos x on 2, that's going to be the same as x arc cos x on 2. So pi x arc cos x on 2 from -2 to 2, but then we also have to integrate this bit here. Oops. Oh, I can't undo it. We've got to integrate that bit there because we've got to bring it to the other side and make it positive. So plus from -2 to 2, it was x on square root x, what was it? 1 minus x squared, a squared minus x squared, okay, so it was 4 minus x squared, because a was 2, dx. Okay, so if we sub that in, we're going to get pi. When I sub 2 in, cos inverse of 1 is 0, so I get 2 times 0, minus when I sub -2, cos inverse of -2 is cos inverse of -1 is pi. So that's going to be -2 times pi. So this is going to be 0, 2 pi squared. Okay, plus over here, if we forget about that, let u equal 4 minus x squared. So therefore du dx will equal -2x, and we can replace that. If we sub -2 in, u equals 4 minus -2 squared, which is 0. And if we sub 2 in, we're going to get 4 minus 2 squared, which also equals 0. So therefore, there's no volume created there. So therefore, our volume is 2 pi squared units cubed. That's our answer. It's nice when that happens with your when you sub them in. Okay, hopefully they're all right. Took longer than I wanted to, but yeah. There you go. Good luck.